This video is just on how to make a toolpath for your CNC to cut the birdhouse. Before we get started, I previously used VCarve Pro instead of Fusion 360, and I just want to address some of the differences. In Fusion 360, we cannot handle large numbers of large STL files that have more than 30 to 50,000 triangles. Fusion 360 will just choke and die on those kind of numbers. In VCarve Pro, there seems to be no limits I've found. I've cut landscapes that had millions of triangles in them, and it looks much better if I do it with VCarve Pro. Also, Fusion 360 cannot handle large DXF and SVG files. If you have very complicated geometry and a lot of it, Fusion 360 may not be able to function for you. However, on the plus side, Fusion 360 is basically free for students and teachers and things, so it's much more accessible. VCarve Pro is quite expensive. The simulator in Fusion 360 is vastly superior to VCarve Pro. And so let's get started. So the first thing to do is to insert our DXF file from the previous class. I have to put it in a plane. So this is the XY plane. You see this green, red, Y, X. I'm going to select that plane. It'd be nice if they put the X and the Y on here. Now I'm going to select the file, open, and there it is. And just needs another second. Okay. Now I'm going to orient head on, and I want this view to be not my front but my top. So I'm going to set the current view as top, and now we see in our cube we have top here. Okay, so now what I'm going to do is extrude all these faces, profiles, into bodies. I'm going to extrude them to a depth of a height of 0.236 because that is the thickness of the material that I've measured. So oops, let me hit the extrude button first. And I'm going to extrude this and this and this and this. Over here, these window sills, I'm going to extrude them like so. A distance of 0.236, and all to new body. Just do it all in one step. Now we have bodies instead of a DXF file to work with. The next thing I want to do is dog bone these corners so that my bit will carve out these corners completely so that everything will fit. Well, in dog boning in Fusion 360, most people use this add-in. So over here we have our add-ins menu, and we can get our add-ins. And I already have the dog bone script in here under add-ins. However, I'll show you how to add it right now. Go Google dog bone script Fusion 360 and you'll get right to this web URL here. This is GitHub, which you may already be familiar with. Then come over here and select download, and then download the zip file. It comes down really fast because it's not that big. When you get it, you want to drop it in this folder here. Type in %, app data, %, Autodesk Fusion 360 API / add-ins. When we get there, I've already dropped the script in, but just drop the folder in just as you downloaded it. Take it out of the zip file first. It'll have these files in it. Once you've done that, then just simply go over to add-ins, script add-ins. These are our add-ins. You'll see I already have dog bone in here. You won't have that yet. You'll have to click this and then select this file, select the folder, and oops, now I got two of them. So once we have that dog bone script, we hit the run button. This doesn't run the script. Watch what happens. I hit run, and bing, I get a new button. This new button will run the script. I click on that, and let's get to work. So the tool diameter I'm using is an 1/8 inch bit. I'm going to output unconstrained geometry because I have no constraints here. I just imported this file, so it'll run much faster that way. And now I can select entire bodies for dog boning, and it will pick up all the corners. But I can only do these ones I've selected here. The reason is that these windows, I don't want them dog boned. If I do, we'll probably lose some of this window framing here. It'll just fall apart because the dog boning will be too much. So I don't want to do these at all. So these I'll do later. I'm going to do these 4 bodies in one step. So I just hit OK, and just takes a couple of seconds, and look at that. It's nicely dog boned, so we can dig out those corners. Great little script. Now something to point out is, suppose I wanted to undo that dog boning. Well, every time you run the dog bone script, you get a new sketch. If I wanted to undo that, all I'd have to do is delete this sketch, and it would reverse everything I've done. Or you could just roll your timeline back. Well, actually, it doesn't show up in the timeline because we're operating. I don't know why it doesn't show up in the timeline. But if you want to undo a dog bone operation, just delete the sketch that it created. All right, let's take care of the other bodies now. So I still got the tool diameter at 0.125, and I'm going to, instead of selecting bodies, I'm going to select the interior edges. So let me get a little bit better angle, and then start hitting all the edges that I want to dog bone. Pretty much like this. If I hit something that I didn't want dog boned, I can hold down the shift key and click again and undo that operation. Alright, so this body is now going to be dog boned. I'll just press OK, and there we go. You see the dog bones right here. Didn't touch my windows. Alright, I'm going to pause for a second and do the rest of them to speed things up. Okay, I just finished running my dog bone script a couple more times to get everything else needed. I'm going to reorient this to the home position. I'm going to change this home position to be, I kind of like that. So I'll just right click here, set the current view home. There we go. So now the next time I click on home, I'll get right to that view. Alright, so now let's move off into our CAM environment. So we're done modeling. Let's go to CAM. The first thing to do is create a setup. The setup describes the stock material that we're going to cut and our axis. So I'll create a new setup right here. And so the first thing to do is set our axis. So I don't want to cut from the middle. I want to cut from the lower left-hand corner, and I want to set my z-axis from the top of the material. So I'll just click there, and that's the simplest way of doing it. That's because I'm using model orientation, so I'll have the same axis as the model that I created. All I had to do was move this around by clicking on these points. If I wanted to reverse something, all I have to do is click on this arrow, and it will reverse. There's other ways of doing this. I prefer the model orientation, but you can select your axis many different ways. We just won't get into that right now. The next thing is we have to describe the dimensions of the stock we're going to cut. So I'll hit the stock button, and it gives us a default sizes. I don't prefer that. I like a fixed box size. I've measured the material I'm going to cut. It's 18 inches by 18 inches by 0.236. Hit OK, and that's my pieces that will come out of my stock. Alright, next up is we need to describe a bit to cut this with. I have a 1/8 inch mana bit, which we're going to be describing in just a minute. I'll put it into a custom library. So I'll create a new library called Demo, just for the purposes of showing you how to create a library and put your bits in it. Bits also reference its holder, so you have to do the holder first. The holder is what I usually call the collet and the collet nut. So the first thing, let's go over to Tool Library. I'll click on that. I'm going to come over to Local and create a new tool library. I'll call it YouTube Demo. Alright, and that will be, say, your personal library for all your bits. The next thing to do is add a holder. So this is new holders, this is new bits. So I'll start with a new holder. Let's give it a little description. ShopBot desktop nut. Vendor, I bought it from ShopBot. The product ID, I just call it an ER20. That's the size of the nut. I do recommend you put in links to wherever you bought it. It's kind of handy if you need another one. It's a good place to keep that information. Next, we have to describe our ShopBot nut. Well, the ShopBot nut has a very simple geometry. We only need to add two different heights here. The first one, the height will be 0.655. The diameter will be 1.39, and that's the upper diameter. The lower diameter will be the same. I'm sorry, yeah, 1.39. Now the next diameter is going to be 0.171, 1.39, and 1.114, and that is our ShopBot nut. Okay, so if I wanted to just change things up a little bit, let me just show you how this works. I could change his height. You can kind of see how this is going. So section 1 is this section here. If I wanted to change, narrow this down, I would probably go to the lower diameter, say 0.5. So it's kind of self-explanatory. Put it back. I recommend just playing with it. In about 5 minutes, you'll have it down. You'll never forget it. So that's my holder. I'll click OK. Next, let's go over some of the terminology before we go ahead and make our bit. So this is a picture of a bit. We have the overall length from here to here. The flute length is just the cutting edge diameter. So in this case, this bit has a rather short one. The shoulder length is from the very tip to where it changes diameter. So if your bit only has one diameter, this measurement's kind of unimportant, and just long as it's inside the overall length, it won't make any difference. Another measurement is how much your bit sticks out of the holder. So if the nut was right here, this would be the body length. The reason why we put in the body length, I think, is for collision detection. So you can make sure that the holder nut won't actually collide into your material at any point by using the simulation, which we'll get to later. Also, diameter refers to the cutting edge diameter, and the shaft diameter is the diameter that goes into the holder. Once again, if your bit has a single diameter, then both of these values will be the same. Now, let's add our first bit, our only bit for this project, to our library. So we're going to add a new mill tool. And before I get started here, I just want to point out that you can go into this library tree and find all kinds of bits from different manufacturers. Let's go over here and select all. So it might be more convenient for you to just select somebody else's end mill and then change it into what you need to speed things up. But for the purposes of what we're doing, we're going to create our own bit. So let me go back now, create a new bit. So we'll start with cutter. So in this case, we're not going to use coolant. Our units will be inches. Let me expand this out a little bit. There we go. Some of the important things we need to watch out for is the number of flutes. We're using 2 flutes here, and I am using an Amana 1/8 end mill. The vendor is Amazon, I guess. Product ID is 45-100. I bought this bit for just 13 bucks on Amazon. It cuts really well. The flute is neither up nor down. It's a straight flute, which works well for plywood in that it doesn't compact the bits, the chips too much. It doesn't extract them real great either, but it doesn't pull the material up off this boiler board. The diameter is 0.125. Shaft diameter is 0.25. The flute length is 0.4375. Shoulder length is 0.4375. All these values, I just measured them with my calipers. The overall body length, remember, that's just the mount that sticks out of the holder. 1 inch will stick out, and then the overall length will be 2 inches. Okay, so that's a good representation of our bit. However, what is this crazy holder? Well, we need to go to the holder we just made and go select the holder. Let's scroll to the bottom. There's our ShopBot holder that we just made. And now we see it looks a little bit more realistic. Now, with our bits, we can save our preferred thieves and speeds with them, which I like a lot. So you might make a copy of this bit for every speed rate that you tend to work with. I've been working with, switch to feeds and speeds, 1200 RPM. I'll pause here while I fill in a few more items. Actually, let's not pause. I'm going to set in the chip rate of 0.003, and you notice it calculates our feed rate for us. So that's our cutting feed rate. It's based off of our speed and our chip rate. If I were to change this value here for spindle speed, it will actually change our chip rate. They call it feed per tooth. I call it chip rate. I don't really like that because this is a fixed number for a bit. So normally I would change this or this. If I change this, I'd expect it to change my cutting feed rate, but that's not how it works. So lead in, lead out, and ramps, I always use 75% of the cutting speed. So I can actually type in 72 times 0.75 and use that, and you see it just fills in the 54. That's nice. So I can do math in these little text boxes. And I'm also going to set that as my plunge rate too. Now notice that if I set this text box, it'll change this one. And if I change this one, it will set this one for me. So whichever one I put a value in, it will change the opposite one. So I'll just paste, and you see that the feed per revolution just updated. Okay, and that's all we need for bits. Let's go ahead and save that, close our library, and now we're going to go ahead and start with contour cuts. So I want to cut these parts out, and I need tabs to hold the material down. So we're going to use a 2D cut. These are your available 2D cuts. Just want to give a point out to this trace here. In trace, we're not going to use it, but it is useful in that if you have a line anywhere in 3D in your drawing, you can make the bit follow that line. And I use that for stick fonts, fonts that have no thickness. And I can make the bit follow that stick font using this trace command. Kind of cool. We're going to use a contour, and we're going to go around these edges. So the first thing to do is select our bit. We're going to go through all these tabs. So the first tab, select the bit. There's our bit. Okay. As soon as we select the bit, our feeds and speeds are all set up for us. Very nice. Now we got to select what we want to cut. So we'll go to geometry, and I'm going to start selecting the tops of everything that I want to cut with the profile. I need to get the inside and outside of these. Something I want to point out is these are all climb cuts. If you wanted to switch to a conventional cut, which just basically means go the opposite direction, you can hit these arrows, okay, and they'll reverse for you. The next thing I want to do is add my tabs. It will automatically add tabs for us if we want. However, I don't prefer its selection. I'm going to make my tab width, my tab height a little higher. Also, I'm going to not do it by distance, but I'm going to do it myself. So I'm going to say at points, and now I'm going to select where I want the tabs. Now if I want to remove one of these tabs or move it, I can just slide it around, but note that it will not go around corners, or at least not around sharp corners. If I want to remove a tab, I just simply hold the shift key and then click on it again. I'll put these tabs down, put one here, one here. I'm going to slide this guy over a little bit. Alright, and I will pause while I do the rest of these. Okay, I'm back, and this is the real reason I wanted to do the tabs myself, was to take care of these very thin, fragile parts. I wanted to make sure I got enough tabs on the inside as well as the outside, and roughly about where I wanted them. And this circle here, he's kind of problematic, so I'm going to put 2 tabs opposite each other there and 2 opposite each other there. Okay, so that's all my tabs. I think I'll just move this guy to the center real quick. Okay. Alright, we're just about done. Let me explain why we're skipping some of these. Stock contours is used to limit machining areas, which we don't need. Rest machining, that is a really, really cool feature. So what rest machining does, we're not going to use it, but keep it in mind, is that if you want to cut with a larger bit and then finish it off with a smaller bit, you use rest machining. That's what rest means, do the rest. And it will only cut the areas that were not cut by the larger bit. Wrap tool path and tool orientation is for CNC machines that have more than 3 axes, which we do not have at the lab. The next thing to take care of is the heights. So I like to think in terms of my stock material. So these are all the different heights, and these are measure froms. I want to measure from the stock bottom for the bottom. I want to measure from the stock top for the top of the cut. Feed height is the height where we would start to ramp into our cut. I'm going to also measure that from stock top. And so let me go back down to the bottom. I want to cut into my spoiler board just a little bit. So I'll set it to minus 0.02 inches. Stock top. I'm going to do a little bit of a trick here where I'm going to start cutting 0.08 above the top of the stock. And what that'll do is my step downs are going to be, we haven't set that yet, but they're going to be 0.1 inch. So on the very first cut, by setting it a little bit above the material here, we will just kind of lightly cut into the material, and this will help prevent splintering in our plywood. So cutting plywood on a ShopBot requires a little extra work. The feed height is where we start to ramp in. That's fine. The retract height, I'll make that a little taller just so I'm certain it clears everything. It doesn't take much longer to go a little higher. And retract height, that's where we how high we go when we're done machining a single tool path. Alright, on to the next tab. We go from heights to passes. So passes, this is mostly for finishing passes, which we're not going to do with our birdhouse, but we are going to do roughing passes. So this is where we set our maximum step over. So the step over is going to be our tool diameter, which is 0.125 times 0.4. So I like to cut into the material 0.4 for each step over. Now you can type in 0.125 times 0.4. You can even do this: tool diameter times 0.4, and it will take that. Moving down, multiple depths. Yeah, we need multiple depths. We don't want to cut this deep with, on a just single pass. So I like to step the tool down 80% of the tool diameter. So the maximum roughing step down will be tool diameter times 0.8. Or you could just type in the value yourself if you want to calculate it on a calculator. Sometimes I will use this order by depth, and what that'll do is it will cut one pass on this contour, and then it'll go to the next one and it'll cut another pass, and then it'll cut this path until every one of these cuts have reached the same depth, then it'll come back to this first one, and then it will cut down again to the next depth, the next depth, the next depth. And the reason why I do that sometimes is it gives me a good chance to, somewhere in the middle, pause the machine and get the vacuum cleaner and suck the chips out of the channels. However, it does incur kind of a time penalty, so you might not want to do that. The next one we're going to look at is stock to leave. So a stock to leave is how much material we would leave. And we have two values. One is the radial stock to leave, which is how much material around the bit we're going to leave. This is a XY kind of value. This axial stock to leave is like a Z value of material to leave. So I don't want to change this, so that'll be 0, but I want to actually cut into the material a little deeper than the plan would normally cut for, by a very small amount, minus 0.005. The reason for that is to leave a little bit of room so things fit nicely and there's room for glue. Smoothing is some optimization stuff we're not going to get into. Feed optimizations is, of course, other optimization stuff of mostly how do I go around corners. We don't really care, we'll just take the defaults. And now for our final tab, linking. This first area is for things like rapid movements. We'll just use our defaults. Lead-ins and transitions, I don't care too much about this. This isn't fine furniture, so I'll use defaults. Ramps I do kind of care about. They have a very low angle ramp as a default, perhaps because people use that for machining aluminum, but I'm going to steepen that angle to 15 degrees. I'm also going to not limit the maximum, the rate at which the ramp can step down, so I'm just going to increase that value to make sure it ends up as 15 degrees. And now we get to hit the OK button and see the toolpath. A few seconds of calculation, and there it is. And let's take a look at it. Looks about what I was expecting. We can see our tabs here. Also, we can see our ramp downs here. I always do this. I'll click on the front just to verify how much I'm cutting into the spoiler board. That's my 0.02 that I'm cutting down. And just kind of check that I clear everything and my ramps all look good. Okay, well, I want to create a second toolpath because we ignored these holes. I don't want to cut those out with a contour. I want to cut them out with pockets. So I'm just going to mill it all out. So the next cut I'm going to create is a pocket, 2D pocket. And now I'm going to select what all is going to get pocketed. So if I click on this, we see our cut here. The area in blue is what's going to get cut out. If I hit this arrow, it will reverse, and I'll cut everything but that area I selected. So I'm going to select all the little window stuff, these holes for the tabs, and these windows here. Okay. I should point out that it automatically selected the previous bit for me and then moved me to this second tab here. If I needed a different bit for this, just hit the select button. So that takes care of this tab. Again, the rust machining is to change bits to narrow, smaller diameter bits and just machine the parts that were left by the larger bits. Very handy. These are for multi-axis machines, and stock contours is for limiting our cut area, which we're not going to do. So I'm going to skip ahead a little bit because the heights and the passes are going to be just the same as in the previous cut, the contours. So I'll pause and set those up. Well, actually, one thing that is different is I'm not going to have any stock to leave. So this and this, other than that, these two tabs are the same. Now let's go to linking. Okay, so this is the linking tab. We don't want to adjust any of these rapid movements. We don't want to adjust any of the lead-ins or transitions. The ramp, we're going to use a helix type. There's many to select from. We're going to increase this angle to 15 degrees and make sure that our maximum step down doesn't slow anything up. And that's pretty much it. So I'll click OK and it'll calculate, and it happens very fast. And now we can see our helix coming in. Oops, I forgot to set multiple heights. Pausing again. Okay, well I can fix that by right-clicking on this pocket and saying, selecting Edit. There we go. And that was passes. I should have had multiple passes. I forgot that. The maximum step down is the bit diameter. Times 80%. Let's click OK. Recalculating. That looks better. Okay. So now that's our pockets. If we want to see all the tool paths at once, we can click on this and this. So you have to hold the Shift key in order to do that. So the next step is to run the simulator. So this is the Run Simulate button. I'll click on that. So just to start out with, I do want to see my stock. So I'll check that, and now I can see my stock. I will make it semi-transparent, and I don't want to see this nut here, so I'll go over to Tool and I'll take off Holder and just show Flute so it's not blocking a lot of information for me. And now I can go ahead and hit the Run button, and then we see our bit cutting away. If I want to speed that up, I can just slide this over. That's pretty nice. Now if I want to go backwards, I can just reverse this timeline, and you'll notice the bit's going backwards and unwinding everything it's done. Pretty cool. If I want to go to the very next operation, I can click on this, and I'll just simply finish up that previous operation. We can see that we've cut our contours through. If I want to finish everything all at once, I can just click this. The simulator is very, very fast, and I like the simulator a lot. So we'll just take a look at this, make sure that everything looks okay. I'll take those tool paths off just so I can kind of see the cut a little better. Now you can see through the stock material and actually see my model. If I didn't want to see the model, I could go back to Model and just unclick View Bodies and then go back to the CAM simulation. I have to select my tool paths and resimulate, and we'll do this real fast, and there we go. Pretty nice. In this case, I might want to take off the transparent and select something that's not so shiny, so I'll just take wall paint and just kind of look everything over. The tabs look okay, they look tall enough, so everything should be fine. So the next step is to create our tool pathing. So this is the post-process button. I'm going to put both of these tool paths into one file. If I didn't want to do that, I would just select one and hit the post-process button. If I want both of them, or any number of them, I just select them before I hit post-process. This folder here, don't worry about it. Where I want the output to go. I'll have mine go to just the desktop, I guess. The program, the name of this toolpath will be, I don't care, Birdhouse. And I need to select what type of CNC device I'm using. So for the ShopBot, I use this Open ShopBot selection. It'll work with, I guess, all the ShopBots. It'll work with the desktop, the Alpha, whatever. If you have a different device or just a different card, say you're using the Tiny G card, you just select it right there, and then we hit Post. And let me change that to the desktop. There we go. And hit Save. And so that's pretty much it. The next step would just be to save your project. And we went over this with the first class. And that pretty much covers it. Thanks for watching my video. That concludes this video.